Hello, this is Mr. Waters, and here's another video for pre-calculus, and in this for the homework. And in this case, I'm going to be doing the homework for page 654 on hyperbolas. And this first example we're going to be finding the equation for the hyperbola, and then we're going to be graphing the equation. And we're going to be given some information. And in this first one, we're going to be given that the center is at 0, 0. We're going to be given that the focus is at -3, 0, and we're going to be given that one of the vertex points is at 2, 0. And we're going to use that information to find the equation, and then we're going to graph it. Okay, now the first thing we will do, since the same procedure that we used with ellipses, with parabolas, and with circles, is we simply plot the information that we're given to start with, and to see what we're given, and to see what we got. Okay, so I'm going to go ahead. There's the x-axis, and there's the y-axis, and we're going to have to graph these points anyway, so we might as well get started right now. Okay, so there's the vertex there at 2, 0, and then the center there at the origin, 0, 0, and then at -3, 0, we have one of the focal points. Okay, and we'll label those at the end when we get the rest of the points plotted. But for now, we can see that the points that were given are all arranged horizontally, in a horizontal manner. So that tells us that this right here, which is the x-axis, that has to be the transverse axis. And so that therefore this is a horizontally oriented hyperbola. So that means its formula is going to be x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Okay? So now in order to figure out the rest of the equation to fill the constants in, we're just going to do the first step of our analysis, which is to work out what A is, what B is, and what C is. Well, we can see from our graph that we've plotted, the points that we've plotted already, right here, we can see that the A number, that's equal to 2. Because that's the vertex distance. Okay? And we can see here that the C distance, which is the focal distance, that's equal to 3. Now we just need to calculate B. Well, we're going to use our handy-dandy formula for that. C squared is equal to A squared plus B squared. So we put C squared is 9, and A squared is 4 plus B squared. So you can see here that B squared is going to be equal to 9 minus 4, which is 5. Okay, so B is equal to rad 5. Now we can also see we're given from the beginning here that the center point of our hyperbola is 0, 0, and all that information is going to allow us to now write the equation x minus 0, which is x squared, over a squared, which is 2 squared, minus y squared, the k number is 0, so that's just going to be y squared, over b, b squared, which is 5, is equal to 1. So our final equation, simplified, x squared over 4 minus y squared over 5 is equal to 1. Remember, in hyperbolas, that a number, the vertex value, does not have to be the largest of the two, a and b, but we are, in our formula, always going to write it first. Now, let's go ahead and plot the rest of the points. And with hyperbolas, we also have to calculate the location of the asymptotes. So a is 2, so there has to be another vertex point at -2, -2. Now we'll go ahead and to kind of neaten this up, we'll get rid of these here. We don't need those marks anymore. So let's remove those. Okay. Okay, so we've got the two vertex points, and now we can fill in the opposite focal point there, right? And so this is 3, 0 for that focal point. This is going to be 2, 0 for that vertex point. This is -2, 0 for that vertex point, and -3, 0 for that focus point. Now, since this is a horizontally oriented hyperbola, our asymptotes are going to have equations y is equal to plus or minus b over ax. So that is rad 5, which is the b, over a, which is 2, and that's going to give us the slope. So the rad b was rad 5, which is about, oh, I don't know, 2.2-ish. So I'm going to start at the center point. To count the slope of your asymptotes, you always start at the center point. I'm going to use, I guess, red for this. And we're going to count over 2 for the a, 1, 2, and then up rad 5, which is about there. And then over 2 for the a, and down rad 5, so that's the negative square root of 5. And that's going to allow me to now just sketch in the asymptote points. We're not plotting points, so I don't need to label those points. They're just there to help us outline where the asymptotes are. Now, the asymptote is not a part of the graph, so I dash it. Okay? And then I draw artistically the hyperbola. That's not very artistically, but you get the idea. Like this, going through the vertices, curling around the focal points, and snuggling into those asymptotes. And there it is. We've got the graph, and we've got the equation. Thank you.